Hi everyone, my name is Frederic Ayala Gomez and I'm here to present our paper. As you may know, there have been some changes in privacy that are reshaping the advertising ecosystem. Our paper is about assigning revenue to advertising campaigns under these new privacy circumstances. Let's start with an introduction on how app developers grow their user base. In general, mobile app developers assign part of their revenue to grow their user base by spending in advertising. The goal is to keep the user acquisition activities profitable. For this, we need to attribute revenue to campaigns. This basically means assigning parts of the revenue to the campaigns that we are paying for to show ads. Comparing the revenue from the campaigns with the spend that we have made help us track if the campaigns are profitable or not. This is usually done at the cohort level. Comparing revenue and spend has been possible thanks to attribution methods such as last click attribution. At a glance, last click attribution assigns the origin of the users to the last campaign the user engaged with, either by clicking or by seeing it. This requires advertising identifiers because with that we can link clicks and installs. However, these identifiers have created a big concern on how much data can be collected and linked to profiles. Starting last year, on the release of iOS 14.5, Apple made a privacy innovation that allows users to choose privacy over tracking. If they do so, there is a lack of identifiers for advertising, which disrupts traditional mechanisms for attributing revenue to advertising campaigns. Traditionally, we have been operating under low uncertainty when it comes to tracking revenue and spend. You can think of a comparison. Let's say online advertisement has been easier to track revenue from the users that you acquire compared to traditional marketing like newspapers or billboards, where it's very hard to assign what made a user purchase. So this privacy innovation affects how marketing teams operate ads on iOS. We can see the impact of these changes on the 2021 Q3. The earnings calls of various advertising networks mention an impact in their revenue. Some of the reasons are the lack of tools for marketing teams to measure ROI under these new circumstances, but also the campaign optimization algorithms lose effectiveness. Undoubtedly, marketing teams need a way to measure the performance of marketing campaigns, even though there are privacy conditions. What are the changes? Here you can see two images. On top is an example of a pop-up that shows to a user every time there is a new application installed on their phone. If the user allows the application to track them, then the identifier for advertising will be shared. If they don't, it won't be shared. This is part of the SKAd network and the app tracking transparency framework. And for the users that do not allow tracking, Apple will send postbacks containing conversion values, and this will be the mechanism to track the performance of campaigns. What are conversion values? A conversion value is an integer between 0 and 63 that the app developers define following a set of rules. You can check Apple documentations for such rules. But basically it's up to the app developers to set the logic of what these integers mean. The users that do not allow tracking will appear as if they would have come organically to the application because there is no identifiers for advertising. Conversion values follow last click attribution, and it is the only reliable mechanism for doing it. For example, fingerprinting is not allowed. One important thing is that under certain circumstances that Apple is not disclosing, the conversion values will be reported as null to protect the user privacy. We have been thinking on these privacy protections rules, and because there is a lack of open rules, we interpret the conversion values mechanism to be something similar like k-anonymity, which requires all of the users to be indistinguishable from at least k-1 other users. On the other hand, if this is the case, it does not guarantee privacy because the condition is not enforced on the null conversion value. Keep in mind that this is our interpretation and the real mechanism is not disclosed by Apple. When we talk about revenue attribution using conversion values, we mean to attribute revenue to advertising campaigns at a certain period of time. You can see in this figure that over time, the revenue accumulates, right? So we will look at a specific period and distribute the revenue that we have seen we have acquired over all of the campaigns and also the organic origin. Our paper is about translating the counts of conversion values that we receive from Apple to revenue. And we focus on attributing revenue to cohorts. As a reminder, a cohort is a group of users that start using the application at the same time, for example, during the same date. All right, let's look at the proposed method. First, let's see the error minimization problem. So what we're trying to minimize is the difference between doing revenue attribution based on conversion values for a certain campaign and the actual revenue that came from that campaign. We found that independently of the conversion value scheme, there is a function that minimizes this error. First, let's see at the case when there is no privacy threshold. And this is just the product of the count of the conversion value by the average revenue of the users with such a conversion value. When there is a privacy threshold, we need to account for the null conversion value. So we propose two attribution formulas. When we have the conversion value, it's the same as before, but for the null conversion values, we have to multiply the average revenue of the null conversion value by a distribution function by the count of null conversion values. For the distribution function, we can use a uniform revenue attribution, which would distribute uniformly all the revenue across networks and campaigns. And the null-based revenue attribution would distribute the revenue based on the empirical distribution of null values. Let's look at an example. Here we have 3 advertising networks and we want to attribute revenue at the network level. For this, we also estimate the count of conversion values for the organic origin. And we do this by looking at all of our users in the database and subtracting the scan data that we have received. The null conversion values for organic are a bit trickier to estimate. But if we are doing, for example, revenue attribution at a weekly level, we could look at what conversion values we didn't receive in a day and flag all those. We can see this a summary of the conversion values. We also have a new table, and that's the average revenue per conversion value. In particular, we are looking here at day 7. So we can calculate this by looking into what would be the conversion value of all of the players in our database independently of their origin. So this information is available. The first step is to multiply the count of conversion values per the average revenue per conversion value. And this will give us the first part of the revenue attribution. Let's suppose that we know that those cohorts by day 7 made $30. And we know from this method that the no conversion values revenue is $17.48. So there is a difference of $12.52 that we need to allocate. Here's where the null conversion values come into play. The first step is to calculate the average revenue per null conversion value, and this is done by subtracting from the total revenue the revenue known from the conversion values and divided by the total nulls. Then we look into the null distribution for the different networks. And finally, we can allocate the revenue by multiplying the null average revenue by the null count by the network null distribution. If we sum what we just allocated based on the null conversion values with the known conversion values, it matches exactly the $30 that we wanted to allocate initially. How did we check that this method is working? Well, we did some experiments using historical data. We look into the data that we had in the past where last click attribution worked with IDFA and backtested on a globally launched free-to-play game where we had more than 500,000 paid players and there were 213 paid campaigns across 7 networks. The investments in this game were significant and the paid players were a big share of all the players. So user acquisition was important for this game. As for the conversion value schemes, we look at 3 types of conversion value schemes. First, we have the day 0 event-based, defining the conversion values based on 6 actions that the user made during the first 24 hours of gameplay. For example, passing a level, reaching certain number of coins, using hard currency, etc. Another schema could be to counting the cumulative spend in the game or the cumulative number of purchases that they have made over time. For this, we extend the tracking window to 1 day, 3 days, and 7 days. Also, we tried to just uniformly distribute the users across the conversion values, which we use as the worst case scenario. And our best case scenario is one very hypothetical, where we would know the exact amount of money every user would spend in the future, and we would use that number to put them in different groups of conversion values. In practice, this is not feasible, but we use it just as a baseline. So let's summarize the results. When there is no privacy threshold, indeed, we see that this perfect lifetime value baseline has the lowest error, and the uniformly distribution conversion value schema performs the worst. As P increases, we see that the day 0 event-based scheme and the uniform distributed schemes performance gets closer to the rest of the schemes. We also observe that using more than 24 hours of gameplay reduces the attribution error. And the schemas that kept track of the cumulative revenue and the count of IIPs work well if there are enough players spending during the observed period. Otherwise, they go to the null value and it doesn't work very well. Empirical results suggest that if we are able to separate spenders and non-spenders and then group them based on the amount of spend we are expecting, this would reduce the attribution error the most. So in conclusion, our work formalizes and investigates the conversion values for revenue attribution. We found an attribution function that doesn't depend on the conversion value scheme, and we shed light on how different conversion values perform in revenue attribution. Separating spenders and non-spenders was the best way to minimize the error for revenue attribution. Thank you very much, and if you have any questions, please reach out.